A reduced quadratic expression is a quadratic expression with one x squared term. That is, it is an expression in the form x squared plus px plus q, where p and q are constants. A very common problem in mathematics is to factor a reduced quadratic expression. In order to factor this expression, we look at the corresponding reduced quadratic equation. X squared plus px plus q is equal to 0. How to factor the quadratic expression depends on the sign of the discriminant of the corresponding equation. If the discriminant is positive, then the expression can be factored as x minus x1 times x minus x2, where x1 and x2 are the roots of the equation. For example, to factor the expression x squared minus 3x plus 2, we consider the equation x squared minus 3x plus 2 is equal to 0. This equation has discriminant 1 and solutions x is equal to 1 and x is equal to 2. Therefore, the expression x squared minus 3x plus 2 can be factored as x minus 1 times x minus 2. If d is equal to 0, then the expression can be factored as x minus x1 squared, where x1 is the single root of the corresponding equation. For example, to factor the expression x squared minus 2x plus 1, we consider the corresponding equation x squared minus 2x plus 1 is equal to 0. This equation has discriminant d equal to 0 and a single solution x is equal to 1. Therefore, x squared minus 2x plus 1 can be factored as x minus 1 squared. We can easily check that this is correct by using a quadratic identity. If the discriminant of the corresponding equation is negative, then the expression cannot be factored. Another useful result related to a reduced quadratic equation is sometimes called completing the square. Any reduced quadratic equation x squared plus px plus q can be written as x plus p over 2 squared plus q minus p squared over 4. You can easily check for yourself the validity of this result by expanding the parentheses on the right hand side. If you want to prove the formula that we have for the roots of the quadratic equation, this is precisely what you would use.